Have you been struggling with projectile motion before? Well, struggle no more. Watch this video till the end. Hello everybody and welcome. Today we're going to introduce projectile motion. Many of you struggled with this topic before, but actually it's easier than you think. But it's very important that you watch the previous chapter, which is kinetics in one direction, because they are very much related. Okay, so let's start. Now, here we will be introducing projectiles, which are simply objects moving in two dimensions. In other words, we've studied objects moving horizontally with a certain acceleration or with zero acceleration, etc. Then we studied the motion of objects going upwards and downwards, and we said that objects moving upwards and downwards are always affected by a constant acceleration equal to g, which is 9.8, and it's always pointing downwards, okay? This question is asked commonly. The acceleration of the gravity, or g in other words, it's always pointing downwards, okay? Now, as we said, in projectiles they will be moving in two dimensions. The first dimension is in the x direction, and it has a constant speed. Now this is very important. In projectiles, the horizontal motion has constant speed. In other words, there is zero acceleration. How will that help us? We'll see right now. In the second dimension, it is moving vertically in the y direction, and it has varying speed. It has constant acceleration. As we mentioned before, this acceleration is going to be equal to g, which is 9.8, okay, as a quick reminder. Now, let's look at this shape here, which describes a projectile motion. As you can see, the object starts moving from this point, for example, and it has a certain velocity, okay? This object has a certain velocity and has a certain inclination angle above the horizontal, which we called theta before, okay? Now we know that velocity is a vector quantity, and we know that vector quantities can be transformed into an x component, as you can see right here. It can be transformed into a y component. How can we do that? You can watch the video that explains vectors in detail. Now we know that the component that's close to the theta angle will take the cosine of that angle, and the component that it's going in the y direction, or it's far away from the theta angle, will take sine of this angle. So what we did here, we transformed this velocity vector into two components, one in the y direction and one in the x direction, okay? This component right here, or the velocity in the x direction, well, it doesn't change. It always has a constant value, because it's mentioned here that the speed is constant and the acceleration is zero. So the x component, it does not change. The x component in a projectile, it does not change. It has zero acceleration. While the y component, as we learned before, it's affected by the gravitational acceleration, which is equal to g, which is 9.81. So the velocity will keep on changing. So what are the equations that we will be using to describe the motion of a projectile? Well, actually, we already know these equations. How is that possible? Well, in the vertical equations, or the vertical motion, we already know that we have covered them, or we have introduced them using the equations of motion, which we saw before for vertical motion, okay? And in the x-axis, well, we said that it has a constant speed, therefore there will be no acceleration. Therefore, simply the displacement will be equal to vx multiplied by t. Vx is the x component. Okay, now let's look back at our drawing here. The delta x here, well, it's the horizontal distance the object moved. In other words, it's called here the range. Sometimes you're asked to find the range. In other words, it's moving from this point here and it's ending up at this point right here. The distance from where it started to where it's ended, it's called the range, or the horizontal distance, okay? Now, the vertical distance, well, it's varying. As you can see, it starts from 0, it keeps on increasing, then it reaches this point, then it goes back to its original position. So delta y here is changing, and we know that delta y can be found out using these equations. Now let's go into this shape in more detail. But first of all, how can we solve a projectile motion? Well, actually, put these steps into your mind, and I think any projectile motion problem will be solved easily. Okay, so the first step is draw the trajectory graph that describes the problem and label all the relevant variables. The second step is you want to make a table of the knowns and the unknowns. So you'll be writing, for example, Vx here is unknown, but time is known, Vy is unknown, delta y is unknown, etc. Third step, you will write these equations of motion. Okay, when you have these equations in front of you, things will be less confusing. And finally, you will solve the equations that only have one unknown, okay? Now, some tips and tricks that we must go into detail so we can understand. For example, it's very important to know that the Vy, or the y component of the velocity, is the same at the same height but with a different sign. Okay, what does that mean? For example, let's say that the object is moving in the trajectory motion and it's right here. Okay, at this moment it's right here. Let's say it has a certain distance called y, and it has a certain vertical component or a horizontal component that has a certain vertical component. Okay, now when the object is at the same height but on the other side of the projectile, for example right here at the same height y, well, it has the same horizontal component, but the y component as a value it's the same, but it's going in the opposite direction. Okay, so it has the same Vy at the same height. Okay, in other words, when it leaves from here, it has a certain Vy called V sine theta. When it touches the ground, again, just before touching the ground, it has a y component that's similar in value to the initial y component right here, but it has a negative value because it's going downward. Something else very important, Vy is 0 at the highest point. Well, we already know that because in motion in one dimension, we described that when an object is thrown upwards at the highest point, it will stop moving, then it will change its direction, and go back. So we can say at this point right here at the highest point, Vx is equal to V cosine theta because we said Vx does not change, but Vy will be equal to 0. Now, third point, and this one is very important, the object is at its highest point at half the time. So for example, let's say that it took 6 seconds from this point here to the end of the motion right here. Okay, for example, it took me 6 seconds. Now, I can assure you that at 3 seconds, it will be right here. Okay, so it will be at the highest point at half the time. Again, so for example, the whole trip took 6 seconds. I can assure you that at 3 seconds, it would be at its highest point. So actually, it's kind of symmetric. Now, we mentioned this one before. Point 4, the velocity in the x direction is always constant. It doesn't change. Nobody needs to tell me that. And finally, if an object was pushed off a table, a cliff, the top of the wall, etc., this means that Vy initial is 0. So for example, let's say we have this building and an object was pushed off this building, so it has an x component but still no y component. So Vy initial in this case is going to be 0. But when it reaches the ground, we know that it will have an x component and it will also have a y component. Okay, so it has two components in this case, but at the beginning it has no y component because it was pushed horizontally. It had no y component. I hope things are now more clear, but in order to master projectiles, watch the next video where we will be solving problems on projectiles. Stay tuned.